Hello, this is Mr. Tejada, and I am going to do a problem here for Hess's law. And so what we have here is we have four different multi-step equations equaling one overall equation. The overall equation is for the reaction up above, and then the other ones are down below. So what I'm going to first do is I just want to recognize that I've got to get to this guy, and also this one. And I want to identify where they're at and where in the problems down below. And we're going to rearrange these four multi-step equations down below so that we can add them together and essentially equal the one up at the very top. So let's just start with the P4O10 solid and try to recognize where that's at. And so I'm going to underline it. I see it right there. Okay, so let's go now for the other one. So we have PCl5. So PCl3, nope, that's not it. PCl3, nope. PCl5 right there. Okay, and let's try the last one, C3PO, almost like, well, you know, Star Wars. It's over here on the right, and I see it right over there. Now, one thing you should notice is that for the blue and for the red, they're on the reactant side of the equation. Over, let me use a different color for just writing normal. Here's our reactants. And then over here we have our product. Okay, and so here we have it on the reactant side, but over here we have it on the product. So one thing that we're going to have to do initially already is reverse that one. And so I'm going to go P4O10. I'm going to leave out the I should probably put them in. Might as well. I'm going to reverse it back the other way so that they match up to be on the same exact side as one another. And when you do that, you now have to reverse the sign on this. So I'm just going to turn this into a positive. All right, now I'm going to do it for the next one as well, because here you see it that it's on the reactant side, but it's over here on the product. So I'm going to reverse this one to the other side. I don't know why I was picking up the red pen, but I was. And this is going to make PCl3. And I'm going to do the exact same thing right there. So now it's going to be a positive. All right, and one thing that I do like to do is once I have these, I like to cross these out. Now you might want to do this with a pencil just in case you make a lot of mistakes. By the way, this is a really tough equation, and I honestly, I'm not sure if I'm going to make a lot of mistakes on this one or not. I probably will, but if I don't, I'm going to surprise myself because it's a lot larger than a lot of the ones that you're going to usually come across. All right, so now let's take a look at this overall, because what we need to look for is things that are opposite of one another, and so then they can then cancel each other out. But the other thing is that we want to pay attention to the coefficients that are in front of here. So we have 1, well, it's not shown, but it's assumed as 1. We have a 6, and then we also have a 10 over here. So if you notice down here for the P4O10, we have 1 here and we have 1 there. So we're all good there. Now we got 6 of these guys, and so let's try to find out where they're at. So we got this guy right here, but it's only a 1. So unless I can find where that PCl5 is somewhere else, where they can then add together, I'm going to assume that I need to multiply this by 6. And if I'm going to try to get this thing to 6 and this guy to 6 so that they're basically the same, and that's what we're trying to do, then I've got to not just multiply this one by 6, but I have to do it throughout the entire equation. So if I do a 6, a 6, and a 6, now what I have to do is I have to multiply this guy by 6. So that's going to equal a new number, and I need a calculator. .84 times 6 gives us 505 point. Let's see if you can see that. 505.2. I do like to circle these. I feel like you really got to pay attention to those signs right there. So I try to draw extra attention to them. All right, so we got that's 6 over there. Now let's go to this guy over here. So this one needs to be, well, 10 times bigger. So I'm going to multiply this entire thing by 10. Now 10 times 1 is 10. 10 times a half is going to give you 5. And then you have the 10 right there. Now we have to multiply this by 10 as well. So let's take out the calculator. So I don't trust my math right now in my head. Actually, I don't know why I wouldn't. That's funny. 2857 kilojoules. Yeah, you just move it over 1 decimal point. Brilliant, amazing. And now let's take a look at these and see which ones can actually cross out, and then you can cancel them out just like you would with any sort of mathematical equation. All right, let me try a different color here. Let's try with like a purple. Here we have the P for, I don't know if you can see that very well. No. Let's try something else. How about this? You see that? Yeah, that's a lot better. You have that right there and you have this right there. There's 1 and 1, so these guys just cancel out normal. All right, so let's go to the CL2s. We have 6 of them there. Let's find where the other ones are. Luckily, we have those guys right there. All right, so those cancel. Nice. 4PCl3. All right. We got to look for the other side. Usually that's where it's got to cancel also out. If this is on the product side, then where it's going to cancel out is from the reactant side, and vice versa. Kind of like if they're on the other side of equals, the equal sign. So PCl3, PCl3. We have 10 of them here. Okay, so sometimes it's a little bit tricky to find them all, because here you have 4 on the product side, here you have 6 on the product side, so that means you have a total of 10 on the product side, and here you have 10 on the reactant side, so this guy cancels out those two. Cool. All right, next ones, let's go over to here. This guy we want to keep right where he's at, so I'm going to write that one down below. So I'm going to add all of these together, and I'm going to get P4O10 solid, and that matches up with up above, so we're good. And now let's go across over to here. I'm using too many pens. And we have 502. Sounds like an area code. We have 502 right there. We have 502 right there. Those guys cancel each other out. We're good. On to the next one. Next line, notice how I'm kind of systematically just going from top to bottom, left to right, just so I don't miss any. Here you have 6 PCl5, so that's what we wanted from up above. So I'm going to do plus PCl5 gas, and that's our red. So you can see that. Whoopsie daisies. Things are rolling around on me. All right, and let's just keep going. Done with this one. Let's go over to here, and we have actually just our last one. And notice how those do not cancel out as well. I need this guy on the back of here. And let's write it down. Good, and that was this one. And now, Hess's law states that the overall enthalpy for the reaction is going to be the sum of all the steps leading up to that, or of a multi-step reaction. So 1, 2, 3, 4. So we want to add this guy and then this guy with this one. This one I should cross out, and this I should probably cross out with that one. We're going to add all those up, and all right, and oops, I was a little bit off the page. Hopefully I wasn't the whole time. All of these. That would suck. Now I'm just going to add these guys up as if this is 1, this is 2, this is 3, and this one is number 4. All right, calculator. I don't want to write them all out. All right. Negative 1, 2, 2. By the way, I don't really trust this calculator too much, so I'm trying to be very methodical with it. And this should be the answer. I don't have the answer key with me, so. But I'm fairly confident in it. And there you go. And we are done.